In forensic entomology, post-mortem interval is used to determine the amount of time passed since the first oviposition on the corpse by a forensically important insect. An insect is considered forensically important when its life cycle depends on the presence of the corpse. This distinction is important as it helps us determine whether an insect is present at a crime scene by chance or if it arrived to oviposit on the corpse. Where insects present at a crime scene have hatched on the corpse, their development can be used to inform the post-mortem interval estimation. This is calculated either using predictions based on the development of individual insects or by assessing the full ecology of the corpse and estimating how much time has passed based on patterns of succession. Where individual insects are concerned, there are numerous factors that may cause an alteration in their speed of development, thus potentially giving an incorrect impression of the time since death. One of these factors is the toxicology of the corpse. This study used an odorless meat substitute to explore the effects of lead as lead chloride at concentrations of 0, 25, 50, and 100 milligrams per kilogram on the larval length of Calliphora vomitoria. This study set out to determine the developmental effects of lead on Calliphora vomitoria by rearing larvae on a diet dosed with lead and observing the difference in length between control groups and each of the increasing concentrations. While the dangerous effects of lead in humans do not necessarily relate directly to what is seen in Calliphora vomitoria, it is evident that lead has a significant effect on larval length. It was found that there is a distinct effect seen where lead concentrations increase. At first, there's a slight increase, a developmental acceleration of about 5.7 hours at 25 milligrams per kilogram. Then, as we get to 50 milligrams per kilogram, it levels off with a developmental acceleration of only 0.2 hours. And by the time we reach 100 milligrams per kilogram, it has dropped substantially with a developmental deceleration of 31.2 hours. It's clear from these results that this concentration relationship is not linear, and there may be a hormetic relationship between the two. As no similar research could be found at the time of writing, this study's data is to be treated as preliminary, a glimpse at the potential impacts of lead on forensically important insects. Further research is needed both to confirm or dispute the results of this study and provide data for concentrations the researcher has not had the opportunity to explore. There are a number of improvements to be made to this experiment were it to be run again. Firstly, to avoid sampling bias, entire pots should be sacrificed each day rather than removing individuals from the pots. Run this way, fewer larvae could be used in each pot, but a minimum of 5 in each pot is advised in order to obtain a mean and determine outlying results. Running the experiment with this alteration for 7 days would require 140 separate pots. This would require either a very large incubator or multiple, which risks inconsistency. To increase sampling speed, it may be useful to use a team of samplers rather than a single person, as sampling 12 pots took approximately 1 hour, and the 140 pot method would require sampling 20 pots per day. The speed of sampling is important because time while the larvae are still left in the food medium is time while they could still be developing, and if you are allowing extra hours for the larvae to be in the food medium, then you may be skewing your results. Another recommendation is to add a preservative to the food medium. This will need its own trial to find a preservative that doesn't interfere with the larval development or the food medium itself. If expired, the mixture will not set properly and the pods containing the lead will separate out into bands. The expired mixture has an odour debatably worse than that of rotting flesh, which it was designed to avoid. Additionally, it would be interesting to keep a separate set of larvae at all concentrations, raising them to adulthood, to check for any health or physiological changes. Finally, it's worth noting that reproductive output of the fly colony may be a limiting factor in the number of larvae available in winter months, even if the room is heated. If you would like to see the reference list, full document that this poster was derived from, or discuss the experiment further, please contact me at greenfrancissmith@gmail.com. Thank you.